This is a fire piston. It's one of the simplest forms of ignition that exists, and it's why diesel engines run. I'm gonna go back about 2,000 years to when this combustion method was first discovered. I'm gonna make some see-through fire pistons. I wanna show you how air pressure alone can create enough heat to start a fire or initiate ignition. Fire pistons like this only consist of a couple of parts. The reason I'm doing this is to show visually the simplest form of compression ignition, which is the same principle that every diesel engine uses. In a diesel engine, the ignition happens because of heat generated by compressing the air, not from a spark plug like in a gasoline engine. This process is why diesel engines are known for being powerful, reliable, and efficient, and it's all based off of the fire piston. I was wondering what that was right there. That's the fuel injector. And if we look at any one of these fire pistons that I made, I based almost all of these off of a 25:1 compression ratio. A diesel, from what I remember, is about 23:1 compression ratio. But in the real sense here, we're gonna be limited by the amount of pressure that we can actually apply. I printed these strikes out on the Formlabs printer. And if we do the math, that means that when this is fully compressed, we have about 370 PSI, which is about 350 pounds on this piston. I don't think I could apply 370 pounds of force that quickly and achieve the compression ratio. I'm just gonna smash the top of the piston with a sledgehammer, put the high-speed camera on it, and see what happens. To achieve combustion, we need three things: heat, oxygen, and fuel. We have heat in the form of compression. We have oxygen in the form of air inside the piston. For the fuel, we're gonna use char cloth. That's what we're looking for. Perfectly charred. For this first attempt with only the char cloth as our fuel, I'm gonna give it a shot. I'm gonna push this as hard as I can, and if it doesn't ignite, I'm gonna hit it with a hammer. Starting to smoke. I smell a little bit of burning, and I'm already sweating from pushing it so much. All right, hammer time. I'm gonna give it my best. Think this is just a little bit too much pressure. So that was a lot harder than I thought it was gonna be. I was trying to be slick and make the fire piston a lot bigger to make it visual for the high-speed camera, but it's all about static pressure. This is about 1 square inch. You need about 400 to 500 PSI to get some heat going there, at the minimum, if not more. That's like 400, 500 pounds that I have to push, and it didn't work. So I'm gonna swap this out with a smaller fire piston, the medium size, which is still gonna give us a good view, and I'm gonna try it again. This time, since it's half the size, it'll be double the pressure. Yeah, let's give it a shot. Wow, that was unexpected, but I think I know what happened. I think previously when I was hitting it, it actually caught fire and I didn't realize it, starting the process of pyrolysis and releasing probably hydrogen gas into the cylinder. So when I grabbed the piston and put it back in and hit it again, it just blew the tube instead of burning. Makes sense. Smells just like diesel. I'm gonna reset this with a new cylinder, a new piece of char cloth, and see if I can get it to burn. Then I'm gonna move on to the diesel. Well, that was pretty incredible. We basically had ignition from thin air. All we had in that tube was air compressed, a fuel, which was the char cloth, and that was it. But that ain't nothing compared to the diesel, which we're about to see next. I foresee a couple scenarios here with the diesel. Scenario one, I soak the char cloth with diesel, and as I compress it, the heat builds up, vaporizes the diesel to the point where it ignites. Scenario number two, I can spray the diesel in there and let it vaporize, and then do the piston, and then it ignites. First, I'm gonna try soaking the char cloth with diesel and see what happens and go from there. First attempt with diesel. I'm gonna try this one more time, but this time I'm gonna put more diesel in the cylinder. I wanna see if I could get more of a combustion instead of explosion. That was even crazier. Well, it looks like the diesel was just too much power and it blew up the tube. So I'm gonna try this again with the smaller tube and see what happens. If that doesn't work, instead of trying to get it to burn over and over again, I'm just gonna move on with my next idea in another video. Let's give it a shot, see if we can actually see some fire instead of an explosion. This piston is much, much smaller. I'm barely hitting it this time. Blew up again. Looks like I had the same result as the previous attempt. That was pretty interesting to me because I got an entire tube full of fire just from a piece of cotton cloth, but with the diesel, it's just blowing up the tube. The only thing I can think of is that the diesel has just so much more energy potential than the fire cloth, so when it ignites, the piston is still traveling in this direction and the pressure has nowhere to go and it's just blowing up the tube. That's the only thing I could think of. I didn't really feel any kickback on the tube or anything like that, but I did find it very interesting that you can create enough heat and energy to start a fire or create ignition just from compressing air. And hopefully you felt the same way, because I'm gonna end the video right here. I have another idea for this that's gonna give a much better demonstration. I'm gonna move that into a new video. But I thought the fact that you can create fire with just air pressure was pretty cool. Let me know what you think in the comments below. See you in the next video. Hunk of junk. Made in Japan? I don't know about that. $1,000 for this module? I just don't see it.